Hello, math learners! Our lesson for today is about logarithmic inequality. And we are going to concentrate only on base 10 logarithm. The learning objectives are: you are going to define logarithmic inequality and solve the logarithmic inequality. Now, what do you mean by logarithmic inequality? It is an inequality involving logarithmic expressions. In solving logarithmic inequality, if the form is f of x greater than 0 or f of x greater or equal to 0, then the solutions are all of the intervals with the positive sign. Also, the zeros of the f of x are part of the solution if f of x is greater than or equal to 0. If the form is f of x less than 0 or f of x is less than or equal to 0, then the solutions are all of the intervals with the negative sign. Also, the zeros of the f of x are part of the solution if f of x is less than or equal to 0. Let us have the steps in solving logarithmic inequality. Number 1. Represent the inequality in standard form. Number 2. Express the inequality in logarithmic function form. Number 3. Determine the zero or the critical number. Number 4. Determine the domain restriction. Number 5. Set up the critical number and the intervals on the number line. Number 6. Test the values of x. Number 7. Construct a table of values. And number 8. Graph the solution set on a number line. Let us have examples. Example number 1. Solve the logarithmic inequality. Given the logarithm of the quantity x plus 7 to the base 10 minus 1 greater than the logarithm of the quantity x minus 2 to the base 10. Now, the given can be written in this form. The logarithm of the quantity x plus 7 minus 1 is greater than the logarithm of the quantity x minus 2. So the solutions, you copy first the given. Step 1. Represent the inequality in standard form. So the standard form of the given is the logarithm of the quantity x plus 7 minus the logarithm of the quantity x minus 2 minus 1 is greater than 0. For step 2, express the inequality in logarithmic function form. So the logarithmic function form is f of x is equal to the logarithm of the quantity x plus 7 minus the logarithm of the quantity x minus 2 minus 1. For step 3, we have to determine the zero or the critical number. So, using the logarithmic function, we have to change f of x into 0. So, change f of x into 0, then we have 0 equals the logarithm of the quantity x plus 7 minus the logarithm of the quantity x minus 2 minus 1. And you can apply the symmetric property of equality. And we can have now the logarithm of the quantity x plus 7 minus the logarithm of the quantity x minus 2 minus 1 equal to 0. And next, you have to isolate the constant. So we have now the logarithm of the quantity x plus 7 minus the logarithm of x minus 2 equals 1. So all you have to do is to transpose the negative 1. Becomes positive 1. Let us continue step 3. After that, you have to apply the quotient rule. This is the expanded form. So this can be written as the logarithm of x plus 7 over x minus 2 equals 1. According to the quotient rule, then you can reflect the base 10. We have now the logarithm of x plus 7 over x minus 2 to the base 10 equals 1. Next, continuation of the solution for step 3. Transform this in exponential form. So what we have, 10 to the exponent of 1 is equal to x plus 7 over x minus 2. Then we have to simplify. 10 to the exponent of 1 is simply 10. And then copy. And then you cross multiply. So 10 times x minus 2. And then the denominator of 10 is 1. Multiply. So you have 1 times x plus 7 is x plus 7. So what we have, 10 times x minus 2 equals x plus 7. Let's continue the solution under step 3. We have to simplify this equation. So all you have to do is to distribute 10 to x. We have 10x. 10 to negative 2, negative 20. And copy x plus 7. Then transpose negative 20. So we have positive 20. Transpose x. We have negative x. Copy 7. And combine 10x and negative 1. We have 9x. Combine 20 and 7. We have 27. Divide by 9. Divide also the other side by 9. So what we have, x is equal to 3. Now, 3 is considered as the 0 or the critical number. Step 4. Determine the domain restriction. Take note, the domain of the logarithmic function is defined only when x is greater than 0. So other values than this, it will make the function undefined. So the function f of x is equal to the logarithm of the quantity x plus 7 minus the logarithm of the quantity x minus 2 minus 1 is defined when x plus 7 is greater than 0 and x minus 2 is greater than 0. And when you simplify this, x is greater than negative 7. Simplifying this inequality, you have x is greater than 2. All you have to do is to reject x greater than negative 7, since the logarithmic function is defined only when x is greater than 0. The domain restriction means the values of x should be between 2 and 3 only. This expression is read as x is between 2 and 3. Next, step 5. You have to set up the critical number and the intervals x between 2 and 3 and include x greater than 3 on the number line because we need to test the values. So remember, the domain restriction is greater than 2. So this is the number line, and we have 2 here, 3, and the original inequality in the given is greater than, so it's an open circle. So this region here is between 2 and 3, and this region is greater than 3. And we will not include this because this is already less than 2. We need only x greater than 2. Next, for step 6, you have to test the values of x. You can choose a value in each interval or region, like in the region x between 2 and 3, you may choose 2.25. Or you can choose another number as long as it is between 2 and 3. And in region x greater than 3, you may choose 4 or other than 4 as long as it is greater than 3. So here, we may choose 2.25. Here, 4. Let us have first 2.25. Substitute the chosen value to f of x. So if x is equal to 2.25, then the logarithmic function we have f of x is equal to the logarithm of the quantity x plus 7 minus the logarithm of the quantity x minus 2 minus 1. Then replace 2.25 to x and 2.25 to x here and 2.25 to x here. And then simplify. 2.25 plus 7 is 9.25. 2.25 minus 2 is 0.25 minus 1. Then you can take the log of 9.25, which is equivalent to this value. And then the log of 0.25 is equivalent to this value, minus 1. Then simplify this part. So negative times negative 0.60, 20, 59, 99, 13 will give you a positive 0.60, 20, 59, 99, 13 minus 1. And the value of f of 2.25 is 0.568201721. All you have to do is to round off this to 2 decimal places. So what we have is 0.57. Next, we have to test the value of x, which is equivalent to 4. So if x is equal to 4, then the logarithmic function f of x is equal to the log of the quantity x plus 7 minus the log of x minus 2 minus 1. Then we have to substitute 4 to x here, change x to 4, and x here to 4. Then simplify. 4 minus 2 is 2. Then simplify. 4 plus 7 is 11. 4 minus 2 is 2. And then you can take the log of 11 minus the log of 2 minus 1, and the answer is f of negative 4 is equal to negative 0.25963733105. And round this off to negative 0.26. So for step 7, you construct a table of values. So the interval we have for x between 2 and 3, we test 2.25 and the result is 0.57. And for x greater than 3, we test 4 and the value is negative 0.26. And the sign of the function here is positive. The sign here is negative. So for step 8, you have to graph the solution set on the number line. Since the inequality is in the form of f of x greater than 0, the interval with the positive sign of the function is the solution. Open dots should be used since 2 and 3 are not part of the solution set. So here, this is the value with a positive sign. So meaning, in this interval, we can have the solution set of the given logarithmic inequality. So the solution set is equal to the set of x such that x is between 2 and 3. Do you have questions? If there is none, let's proceed. Example number 2. Solve the logarithmic inequality. We have the logarithm of the quantity x squared minus 5x plus 6 is less than or equal to the logarithm of the quantity x minus 2. For the solutions, step 1, we have to represent the inequality in standard form. So this is the given. The standard form is the logarithm of the quantity x squared minus 5x plus 6 minus the logarithm of the quantity x minus 2 is less than or equal to 0. And for step 2, express the inequality in logarithmic function form. So we have f of x is equal to the logarithm of the quantity x squared minus 5x plus 6 minus the logarithm of the quantity x minus 2. For step 3, you have to determine the zero or the critical number. So this is the logarithmic function. You have to change f of x to 0. So replace f of x by 0. Then what we have is 0 is equal to the logarithm of this trinomial minus the logarithm of this binomial. And then apply symmetric property of equality. So what we have, logarithm of the quantity x squared minus 5x plus 6 minus the logarithm of the quantity x minus 2 equals 0. Still under step 3, we have to apply the quotient rule. This is the expanded form. So the single form now is the logarithm of x squared minus 5x plus 6 over x minus 2 equals 0. And we can reflect the base 10 so that we can change this later on into exponential form. So what we have is the logarithm of x squared minus 5x plus 6 over x minus 2 to the base 10 equals 0. Then transform this in exponential form. So what we have, 10, because the base is 10, then raised to 0, because the result here is 0, which will serve as the exponent, is equal to this expression. So we have x squared minus 5x plus 6 over x minus 2. Then simplify 10 to the exponent of 0, which is equal to 1. So what we have, 1 is equal to this expression. And you can factor the numerator. So what we have, the quantity of x minus 3 times the quantity of x minus 2. And then, still under step 3, so let us simplify. You can cancel x minus 2 and x minus 2 here. So what we have is 1 is equal to x minus 3. And you can transpose x, so we have negative x. Transpose 1, we have negative 1. And combine, what we have is negative 4. You can simplify this part. You can multiply each member of the equation by a negative 1 or divide each by a negative 1. Then we can have x is equal to 4. Now 4 is the value of the 0 or the critical number. For step 4, we have to determine the domain restriction. So, given the function f of x is equal to the logarithm of the quantity x squared minus 5x plus 6 minus the logarithm of the quantity x minus 2. So, this is defined when this trinomial is greater than 0. And this binomial is greater than 0. Then let us simplify. You can factor this. We have the quantity x minus 3 and the quantity x minus 2 greater than 0. And we can solve each factor. We can have x minus 3 greater than 0, which is equivalent to x greater than 3. Next, for x minus 2 greater than 0. Transpose negative 2, what we have is 2. So we have x greater than 2. And also with this, x is greater than 2. Since the domain of the logarithmic function is x greater than 0, then x greater than 2 and x greater than 3 are the possible restrictions. So we have to plot x greater than 2 and x greater than 3 on the number line to determine the correct restriction. So this is the number line, and x greater than 3 is from here going to positive infinity. And x greater than 2 is from here going to positive infinity. Then this portion is the intersection of the two inequalities, meaning the correct restriction is x greater than 3. So the solution set of x greater than 2 and x greater than 3 is x greater than 3. So the domain restriction is x greater than 3, which means the values of x should be between 3 and 4. For step 5, since the domain restriction is x greater than 3, we set up the critical number and the intervals x between 3 and 4, and we need to include x greater than 4 on the number line because we need to test values. So this is the number line, and we have 3 here, 4 here. This region is represented by the interval x between 3 and 4. This region is represented by the inequality x greater than 4. We are going to use the solid dot or the closed dot because the values 3 and 4 are included in the solutions and it is reflected in the given less than or equal to symbol. For step 6, we have to test the values of x. Choose a value in each interval or region, like in x between 3 and 4, you may choose 3.5. And in x greater than 4, you may choose 5. So here, in this region or in interval x between 3 and 4, you can choose 3.5 or any number as long as it is between 3 and 4. And in this region represented by x greater than 4, you may choose 5 or any number greater than 4 and substitute the chosen value to the function. So if x is equal to 3.5, then substitute 3.5 to x. So what we have, x here will be changed to 3.5 and then you square. Then x here will be changed to 3.5 multiplied by a negative 5 plus 6. And x here will be changed into 3.5. And then simplify, what we have is 0.75 on this part. And here, it is equivalent to 1.5. Then, take the logarithm of 0.75. This is the equivalent value. And the logarithm of 1.5, this is the equivalent value. You may check the values using your calculator. And what we have is f of negative 3.5 is equal to negative 0.30102999957. And then you can round off to negative 0.30. Then, for x is equal to 5, what we have, f of 5, and this is the given. Then, substitute 5 to x, 5 here to x, and here, change x to 5. And then, taking the log of this expression minus the log of this expression, it will give you 0.30. Again, you can use your calculator to check the value. So, for step 7, construct a table of values. And this is the table of values. We have the interval x between 3 and 4. We test the value 3.5 and the result is negative 0.30. For x greater than 4, we test 5 and the value is 0.30. The sign of f of x here is negative because it's negative 0.30. And the sign here is positive because it's positive 0.30. And for step 8, graph the solution set on the number line. Since the inequality is in the form of f of x less than or equal to 0, the interval with the negative sign of the function is the solution, including the 0. Then, solid dots should be used. So here, this is the interval with the negative value. So, highlight this portion and this is your solution set. So, x between 3 and 4, all the values here can be the values of the given logarithmic inequality, including 3 and 4. Then, let's recap. So, the steps in solving logarithmic inequality are the following. Represent the inequality in standard form. Express the inequality in logarithmic function form. Determine the zero or critical number. Determine the domain restriction. Set up the critical number and the interval on the number line. Test the values of x. Construct a table of values. And graph the solution set on a number line. Do you have questions? If there is none, then see you next time. Bye!